range of about 20 miles and considerably shorter ranges in usual practice. The committee therefore examined to set in motion immediate and secret experiments on more elaborate lines at a station chosen for its remoteness on the east coast. Here at Orford, in May 1935, a small parallel experiments were started on the shorter wavelength of 13 meters. The choice for mobile requirements of a wavelength half that of 26, conferring a sufficient reduction in size and height of aerials to make gear based on this wavelength a practical proposition on portable masts. By early 1937, the mobile equipment now transferred to Bordze, where the major 26-meter experiment had preceded it a year previously, had solved the problems of range, sense, DF, and height. And in March of that year, the first radar three-dimensional fix was achieved. During the summer, the transmitter was all round. The receiver equipment being one-man operating group in February 1940. At an early stage at Bordze, the necessity for the development of some equipment whereby friendly and hostile aircraft could be distinguished was apparent. In the IFF identification, experimentation from 9 transferred at the outbreak of war to a temporary home in Dundee, and later as TRE to more permanent quarters at Swanage. Minutes delay involved in passing information to the filter room. Could be eliminated by controlling the fighter direct from the ground RDF station. It was realized that accurate fighter direction demanded a new form of display which would present both range and bearing information in such a way as to give the ground RDF operator the target's planned position immediately, and 1.5-meter jammers, the first occasion being the Scharnhorst and Gneisner tunnel episode, stations in the Dover valves, the cavity magnetron, and the klystron, became available by the summer of 1940, providing opportune solution to the problem. Successful air defense would not have availed had the sea routes for food and essential imports proved impossible to defend. Early Bordze experiments on airborne 1.5-meter RDF had shown that returns could be obtained from ships, and shortly after the outbreak of war, ASV Mark I was fitted to Coastal Command Hudson's and Sunderland. Homing beacons were set up, and the ASV equipment was used for homing on return from patrols, range limitations restricting the equipment's use on hostile ships and submarines. Better aerial design giving improved ranges led subsequently to the development of long-range ASV Mark II, the equipment becoming operational by July 1941. Used until early 1942, mainly for locating convoys during escort duty, ASV Mark II, with gradual improvement in ranges, registered increasing successes in night attacks on shipping. Senegat, Daventry, and Ventnor was ready to operate in July 1941, in conjunction with 24 handmade airborne sets fitted to 115 Squadron. By February 1942, several hundred aircraft had been equipped, and a month was spent in practicing on the back radiation of the chain over image positions of German targets. The first Gs were now carried out using the helical AI scan in a Blenheim with a beam tilted downwards, and responses of isolated targets were discernible on the range azimuth display. This immediate success initiated the program of research and development which resulted in H2S, the bulk of this program being carried out at TRE's new home at Malvern. The beam, broad in elevation, and narrow in azimuth on their way to attack by our own protective fighter sweeps. The coverage of the enemy's long-range equipment. The second equipment, 3 fighters so fitted, causing the entire enemy fighter force in the Cherbourg area to become airborne. In 1941, directional listening apparatus, which considerably increased the range of initial AI contact, was carried by fighters to enable them to home onto the AI transmissions of enemy fighters. It was used in conjunction with normal AI in defense of our bombers. By winning the day battle of Britain in 1940, survival to fight and win the night battles of the Blitz in 1940-41 had been secured. This further victory making possible the Allied air offensive in 1942-43. But this offensive, though it accomplished havoc among the enemy's world, our sweeps over France and enabled them to force back enemy aerodromes from the coast. In the English Channel, from March to August 1944, Swordfish, equipped with ASVX, hunted down E-boats, R-boats, and midget submarines. On detection, flares were dropped, and bow fighters, judging their ranges with AI Mark 8, attacked the illuminated targets with rockets. Enemy radar installations were either destroyed, jammed, or deceived by counterfeit presentations. For their destruction, exact plotting on the map was necessary, aided by ping-pong, a listening-in device. Jamming was accomplished by shipborne mandrill and carpet, and by airborne mandrill and the VHF jammer airborne cigar. The contrivance of radar signals misleading to the enemy involved at least one completely novel maneuver. This was the dropping of window by orbiting planes to simulate shipping approaching Fécamp and Boulogne. G and GH guided the planes taking part in these operations. Spoof signals on the enemy's CRT were reinforced by shipborne moonshine and ship-towed balloons. At the last moment, enemy gun positions were bombed and rocketed by aircraft using Ober. Window and mandrill were used in screening the transport of airborne troops carried by aircraft using G. As a supplementary navigational aid, Eureka beacons were set up in England and on ships in the Channel. Supplies and reinforcements were guided to the right spot by aircraft using Rebecca Eureka. This interrogator and beacon system, originally evolved in 1941 and adopted for the dropping of supplies to partisans in occupied Europe, had been employed also in the Sicilian and Salerno landings. The ships sweeping channels through the minefields were guided by G.